Hey! Yeah! Yeah!
What? What time is it? Wait, what day is it? What year is it? Hi folks, I'm here at Sefton Motors with a quick update on our heat engines, the Melvin in particular. And as you can see, it's November. Yesterday it was 70 degrees, and today it's snowing outside. All right, anyway, we'll get right to it. We're going to do a quick overview of the engine and a few other items, and then we'll get into more detailed updates as required. All right, I'm going to start right at the hot end here, and this is what you're looking at here is our newly designed firebox. This one's been through a number of trials, so it's looking a little rough, but this will give you the general idea of some of the updated features. You can see this one is set up for propane. It's hooked up to propane, comes in through into this pipe burner, and we do have a valve on there and a safety sensor, naturally aspirated. There's nothing blown in there. On this side of the engine, you can see our cartridge, our wood-burning cartridge is in place. This cartridge just slides on, slides off to the firebox. Very nice, and it would be the same place that the oil burner front end would slide into the fire. And that oil burner front end would look something like this and burns something like this. Very clean burn, gets very hot. Firebox. As I move back, it's a little temperature gauge there. And I don't know if you can see in there, but they're just simple. It's just a simple tube burner. Lid looks something like this. Moving on to the actual Melvin engine here. At the hot end of the Melvin, what we've done is we've added a crown to the inside of the hot cap, what we call the hot cap, to increase the surface area, heated surface area for the air coming into the hot zone. We've also added a couple more fins to the hot end, and this just helps. It's kind of like a heat capacitor. Another new feature to the engine is this external regenerator. And this actually, we weren't sure how much it was going to contribute to the cycle, but it does speed up the cycle quite a bit and helps the engine to be more efficient and reduces some of the load on the displacer for cooling the working fluid. Inside of this external regenerator, we do have some aluminum elements, and you can see there's a split here between the hot side and the cold side of it. This is the water jack of the engine, which we've dramatically expanded. We wanted to add some cooling capacity to the engine so that you can run at higher temperatures, get higher power out of it. This holds, I want to say, about 12 gallons of water. It's a simple hose input here, and there's another one on the bottom for the hose output, for the water output or fluid output. Looking inside the chamber, I'd see something like this. You'll see that's the expanded metal we have along the internal diameter of the chamber, which helps with some of the heat transfer as that air comes back and forth. Coming back a little further, this is our kinematics housing or crankcase, whatever you want to call it. You can see we have a couple of ports here. One is a simple pressure gauge, just like the one on the chamber. And then there's also the quick connect for the pressure input to pressurize the engine. So the engine can start at ambient and then pressurize it. You do have to still hand start the engine at this point, so you have to get access to the crankcase to start the engine, but then you can close it and actually increase the pressure if you wanted to increase the power output. This is inside the engine. You can see the piston up there. You can see we've updated the linear mount, so lower friction design works very well. And then we've also changed the gen head. We went with a commoditized hub motor, which is working pretty well for us. Less expensive, more of a commodity, and also it'll allow us to go to the remote start capability once that's ready to go or not. We've also changed the rear cover so that it's just a simple hinge with locking nuts. Then coming around to this side, you can see here we're taking the power out with the AC coming off the gen head is going into a bridge rectifier, and you're getting DC out of it. And that's really about it. We'll go into a little bit more deeper dive on some of the elements and some of the other updates. But that is the updated Melvin in a nutshell. All right, the other piece of the Melvin that we've updated quite a bit of testing and changes to is the displacer, and that's what you're seeing right here. It's standing on its head, the hot end at the bottom right here, and coming back to the midsection, which we call the regenerative section of the displacer, and then to the cold side. Now, this is a bit of a mock-up, so don't mind the aluminum tape, although it does hold up pretty well. But to give you just a sense here, we've gone to what I call a fuzzy displacer. I don't know if you can see it, but we have an expanded aluminum, and then underneath it we have a metal wool. And it works real good for stripping the heat out of the air as it rushes by. Down on this end, on the hot end, we've gone to a stainless steel can as the base structure, so it allows us to handle a higher temperature at the hot end of the engine. And then here underneath it, you can't see it, but there's an aluminum can under this middle section of the displacer. And then at the cold end, there's about 8 inches of foam that's underneath this section of the displacer. So it allows us to get to some lighter weight and just be a little bit more efficient in the running of the displacer. That's we spent a lot of work on this guy right here. Although this particular one has been through the mill and it looks a little rough, but you can get the general idea of what's been updated or changed in the design, and it's a much more rugged element of the engine at this point. And here are just a couple glamour shots to give you an overview of the entire engine. All right, the next update is the Melvin Jr. This is an exciting development for us. This is the Melvin pint size, about half-size engine. It's going to put out in the just hundreds of watts, maybe 100, 200 watts, depending on the pressure and the temperature. Here you can see it. It's almost exactly the same as the Melvin Senior. We've only shipped 2 of these. It's still kind of in a beta designation, still a little rough, but it is about half size, physical size, a little bit over 100 pounds. And the key difference in this is in the displacer design. We went and used a food grade type of can or coffee can for the individual elements of the displacer. Here you can see a piece of it here, the smaller one, and that has a rolled cap on both sides, which eliminates the weld of the caps. With pressure on, pressure off, welds are not your friend in a Stirling engine. Here you can see comparison of the Melvin Jr. to the Melvin Senior. And as I mentioned before, we've got 2 of these out there, one in New Hampshire, and this one here is down in Guatemala. Now look at these guys are going to town on it. El Torito, the little bull. So that's the Melvin Jr. Exciting engine. You can find out more about it on our website. Next up is our remote control operation of the engine. This is not yet available, but we've made a lot of progress, so we want to show you that. This is a circuit board, populated, see the battery, and then we've got the harnesses and sensors ready to go. It has not been tested yet. It's not for sale, but we are making progress on it. We do have an app created for it. It's going to be a simple interface, allow you to start the engine, stop the engine, and see what's going on with it via Bluetooth to start. All right, next up on the agenda is our computational fluid dynamics. We hired a guy in Budapest to create a model for us, showing us the heat transfer dynamics going on inside the engine. And what you're looking at here is the output, graphical output of that analysis. On the right side is the hot end, and on the left side is the cold end of the engine. And as you can see, as the displacer and piston move back and forth, that's the displacer, what you're seeing, you can see the change in the flow of the air in the engine and the change of the temperature of that flow of the air. was very illustrative in how the air swirls within the engine, and that was helpful for us in developing some of the crowns in the engine that we use now in the hot and cold end. This is about a 3-second run that took over 48 hours of runtime on a bunch of Amazon computers. Here you can see a couple of outputs. This is just a simple temperature, the hot and cold, hot on top, cold on the bottom. It's in kelvins. And then this next one is the heat flux from the different components of the simulation into the working fluid. Very interesting stuff. Well, that about does it, guys. Thanks so much for watching. Hope you enjoyed it, seeing one of the coolest engines there is. And we will look for you on the other side. You know, I've been working on this project for a number of years. Many times it's just me. But there have been a lot of people who have helped. Hemeth from India. Venkat, James Bond of India. Of course, Lokesh and Sharuk. This guy's doing Cassie in the wintertime. And there's old Storm. It's the grappler. Eamon and Skylar. And of course, the coffee crew. And that's Melvin in the middle. And then there are these two wackadoos. Yeah, they don't really do any work, but I do love this clip. Thanks, everyone, for your help. All right, guys, that'll do it for our engine update. Let you know where things are at. Go to our website, seftonmotors.com, for more information. Send money, send help. What you're looking at here is a test run of one of our latest engines. It's my hand on the flywheel slowing it down. We've reached speeds upwards of 250 RPMs. About a year ago, we were probably at 120 RPMs. More RPMs, more power. Also, we started to put some content out on TikTok. Look for us, Sefton Motors on TikTok. Have some fun. And as always, get hot and run. Talk to you on the other side.